Hi, in this video we present more qualitative results of our CVPR 2020 paper, Multimodal Future Localization and Emergence Prediction for Objects in Egocentric View with Reachability Prior. We would like to acknowledge IMRA Europe for the funding to this work. For more details, you are very welcome to contact them. We start by showing future localizations for various objects such as cars and pedestrians in 4 challenging traffic scenarios selected from 3 datasets. Our first scenario is from Waymo Open Dataset, including a car changing its lane to take the right exit on a highway. On the left, we observe the scene for 1 second. Here the car is driving in front of the Ego car. On the right, we see the future localization of the car after 3 seconds predicted by our method. We show the green boxes for the components of the mixture distribution, the heat map for the distribution of each mode, and the pink box for the ground truth. As expected, the future is almost unimodal, indicating the car will continue driving forward. Now the car is approaching the lane extension of the road, and we start predicting our future to be more diverse, for both staying in the same lane and switching to other lanes. Now that the car decided to go right, our prediction is narrowed down to cover only the 2 right modes. Now the car finished its maneuver and the future is unimodal again, indicating that the car will most likely stay in the most right lane. In the second scenario, we observe the pedestrian waiting at the sidewalk, and then suddenly starts running to cross a street and then unexpectedly cross the next street. The pedestrian is slightly moving, showing no evidence to cross the street at a fast pace. We predict the obvious mode for the pedestrian to move slightly and unlikely mode for suddenly crossing, which is the true future. Note that the heat map indicates that suddenly crossing has almost 0 likelihood. After seeing that the pedestrian decided to cross, our prediction is multimodal to cover different speeds. Now this is an interesting part where the pedestrian decided to cross the second street. Note how our method predicts 3 modes with different likelihoods. A primary mode for reaching the sidewalk, less likely mode for crossing the second street, and an unlikely mode for slowing down. Now we see clearly that the pedestrian is going to cross the second street. Our prediction is unimodal again. Interestingly, we also predict an unlikely mode with almost 0 likelihood for changing direction and going back to the middle of the crossing. And finally, the prediction is unimodal for reaching the sidewalk. Our third scenario is from Nassim's dataset, where a car is approaching the Ego car to turn right and the Ego car is turning left. Here we observe the car is approaching and the Ego car is turning left, which shows a significant large ego motion. Since the car has not yet decided, we predict 2 modes, one for driving straight and another one for yielding. Notably, the predicted aspect ratios fit well to the depth of the car. Now the car decided to turn right. Our prediction is multimodal to cover different speeds for the turn. Unlike the previous prediction, the aspect ratios are similar. Since we don't see the upcoming street yet, we don't know if it's a one-way or two-way street. Therefore, our prediction has multiple modes to cover both options. Now we see how the street looks like, hence our prediction is peaked and unimodal. As the term finishes, the prediction stays unimodal. Our last scenario is from our fit dataset, showing the generalization of our method to unseen and noisy dataset. Here a car is driving in a roundabout and will turn right to exit. As the exit approaches, we predict 2 modes, the car to continue on the roundabout or to turn right to exit. Now the car decided to turn right. Our prediction is unimodal, covering the mode to exit the roundabout. Now we show a comparison between our method and the Bayesian baseline for the scenarios we have seen. For the first scenario, both methods start predicting unimodal future. As soon as the car started changing lanes, our method predicts multiple modes compared to the unimodal prediction of the baseline. For the second scenario, both methods predict unimodal future in the beginning. Here our prediction is multimodal, covering the ground truth, while the baseline is still unimodal. For our third scenario, our method predicts two modes while the baseline predicts only one. Even when the prediction has to be unimodal, the location of our modes fits much better. Same observations apply to our last scenario, where our method has much better diversity compared to the baseline. Thanks for watching.